Hello, grade 6 teachers. Today we're going to look at MAFS 6.NS.3.6. Unpack the standard. It's a rather meaty standard, so we have to do that. Look at what the teacher should be doing, as well as some things that students should be doing to show mastery of the standard, and anticipate some misconceptions and how we can address those if they occur. So let's get started. So the standard says, understand a rational number as a point on the number line. Extend number line diagrams and coordinate axes familiar from prior grades or previous grades to represent points on the line in the plane with negative number coordinates. So coherence should be jumping out right there that they do have prior knowledge of plotting points, and now we're going to extend that to the other quadrants besides the first. Recognize opposite signs of numbers as indicating locations on opposite sides of 0 on the number line. Recognize that the opposite of a number is the number itself. So the opposite of -3 is 3, and that 0 is its own opposite. So 0 again is called out explicitly in the standard. Understand signs of numbers in order pairs as indicating locations and quadrants of the coordinate plane. So looking at the values of the x and y coordinates, the signs of those numbers, and we should be able to determine what quadrant that point should be in. Recognize that when two order pair differ only by signs, the location of the points are related by reflections across one or both axes, and then we'll dive into what that means in a second. And then find and position integers and other rational numbers on the horizontal and vertical number line diagram. Find and position pairs of integers and other rational numbers on a coordinate plane. So again, there's a lot going on there, and let's unpack it. This standard's focus is really conceptual of rational numbers, which include integers with use of both horizontal and vertical number lines, as well as the coordinate plane. Students move from graphing points on the number line to graphing points in the coordinate plane. They extend graphing points and reflecting across a 0 on a number line to graphing and reflecting points across axes on the coordinate grid. And then students are expected to plot coordinates in all 4 quadrants for this standard. I'm looking at what the teacher should do for this standard. First thing is just facilitate some discussion around the number line that allows students to discover that a number and its opposite are equidistant from 0. The opposite sign shifts the number to the opposite side of 0, such as -5, stated as the opposite of 5, which is -5. Just remind students that 0 is its own opposite, and the opposite of the opposite on a number line is the number itself, such as the opposite of -5. And so you can illustrate that I just quickly on a number line here. So we can start with 5, and the opposite of 5 is -5. Those are equidistant from 0. You can emphasize that point. And so the opposite of 5 is -5, and then its opposite, the opposite of -5 takes you back to 5. And so have students experience that journey themselves, and so they can really come to the realization on their own that the opposite of opposite is the number itself. Also, engage students in activities that have them place rational numbers in different forms on a number line and justify their order. So again, a math practice 3 opportunity here where, if you can mix in some numbers like -3.5, 1, 4 2/10, -5, 9/2, and so you just give them, 5 or 6 numbers in different forms and have them place those on the number line. And so they have to attend to order and the magnitude of the number for those. And so also we can set up opportunities for students to graph points in all 4 quadrants and make the connection of the sign of the x and y coordinates of each. And so through experience, have them discover as you're plotting different points. Let me zoom out here. In the quadrant plane, here's your positive, positive, negative, positive, negative, negative, positive, negative. And so, through experience, have them discover that. The other piece, though, that I think is something explicit that we need to draw some attention to is allow students to discover the relationship between 2 order pairs that have a different sign. And so let's say 3 and -4. So we have +3, it's +3, -1, 2, 3, 4. So we're here. And then we have 3, 4, 3, 1, 2, 3, 1, 2, 3, 4. And so having them, so we have 3, 4 here, 3, -4 here. And so having the students see that this is just a reflection across the x-axis here. Or we could have, we could have 3, -4, and -3, -1, 2, 3, 4, -3, -4. And then here how we have a reflection across the y-axis. And so that's something called out in the standards, and they have to realize that points that just differ by sign are reflections across axes. And if we even had over here, if we had -3, +4, so I think that's right here, so -3, +4. To get from +3, -4 to -3, +4, just same numbers, different signs. That's a double reflection. So we could have reflected over the x-axis then the y, or over the y then the x. And so that would be 2 reflections to get there, when the only thing that's different is both signs are different. So let's look at some of the things that students should be doing. And so the students really need to understand the meaning of the word opposite and be able to plot opposites on the number line. Reason about the opposite of the opposite being the number itself. And don't forget to include the number 0 as well. They have to make sense of the opposite of 0 being 0, and even the opposite of 0 being 0. Describe quantities having opposite values. Use vertical and horizontal number lines for integers. And then also plot integers on the number line and the coordinates in all 4 quadrants. Students also need to be able to understand that the ordered pair is composed of 2 parts. That first part refers to the x-axis, that x-coordinate, and the second part refers to the y-axis, that y-coordinate. They need to recognize the signs of all ordered pairs on the coordinate plane for each quadrant, with that first one being your positive positive, second being your negative positive, third being your negative negative, and fourth quadrant being your positive negative. They need to understand that changing the sign of one or both numbers in the ordered pair will create a reflection of that point. We showed you that on the teacher side, where it could be a reflection over the x-axis, y-axis, and when both signs change, a reflection across both. And then they need to be able to find reflection points across axes. So addressing some misconceptions. Some students might not understand that changing the sign of a number changes the location, the same distance opposite of 0. Maybe go back to the number line. Have students measure using a ruler on a number line to prove that it's true. And so again, the more experience they can have with the physical, that concrete representation, the better. Some students may confuse the quadrant labels 1 through 4 going counterclockwise, and so encourage students to label their quadrants every time they plot order pair, so until it's no longer needed. So again, it's not something that we have to dwell on, but if they are having trouble recognizing which quadrant's which, just have them label those quadrants until they don't need to do it anymore. And some students may confuse 3 and -4, 3, thinking both order pairs look the same. And so again, using paper folding, GeoGebra, Desmos, mirrors, to help students understand that the connection between the signs of the coordinate and their reflections. And so you can show them that 4, 3 and -4, 3 is that reflection across the y-axis. So thanks for watching. If you have any questions, feel free to contact me or your regional specialist. And thank you for making PascoMath more awesome.